Okay, so I'm super excited because this is the last video for today. We're talking about the dependent t-test, so let's get this one finished. So the first thing we're going to do once again is to give you that formula, so hopefully it'll make sense in your brain as we go through the 4 steps of hypothesis testing. Once again, don't forget we have hypo testing has 4 steps. I condensed it to 4 steps because it's so much easier. State your hypothesis, there's 2. Set your criteria, there's like 3 criteria we're going to talk about. Then we're going to compute, in other words, run our test and analyze it. And step 4, make a decision based on APA format because this is psych stats. So if we look at this, the last formula is looking at the dependent t-test. The dependent t-test, like I told you, is simply looking at one group of people and we're asking them something twice. A pre and a post, a decision between 2 products. We're looking at a design where the same group is asked something twice. So if we're asking the same group something twice, we have a mean difference. The difference between the 2 choices given to that sample minus the mu difference, which means the population's mean difference. And the population shouldn't have a preference over vanilla versus chocolate, over music versus non-music. So if this is the null hypothesis, which means there is no change and there is no difference, this would equal, once again, 0. So do we even really need this part of the formula? No. So what do we actually look at? The mean difference amongst the samples, because remember, t-tests are looking at samples to predict populations because less information is known about the population. And if we're doing the bottom of the test, we're looking at the SMD, the estimated mean difference. And so because we only have one sample, we can once again use the formula, either the variance over the sample size square root, or we can use the standard deviation over the square root of the sample size. It just depends on what information is given within the actual research problem. Or remember, you can also start with sum of squares and you'd have to work your way into these as I explained in a previous video, and I'll also explain in another video later. All right, so let's get started with our example for the dependent t-test. And once again, we'll read it, we'll pull our information, we'll run our 4 steps. So research has shown that losing one night's sleep can have a significant effect on your performance, specifically problem-solving skills, which we all know that could be true. To demonstrate this phenomenon, a sample of 25 college students was chosen and given a problem-solving task at noon following 8 hours of sleep, and then again the next day following a previously sleepless night. For each student, the first and second scores were recorded. For the sample of college students, the mean difference came out to be 4.7 points. Better on the first test than on the second. And the variance was 64. So does the data indicate a significant difference in performing at a 5% level of significance, or in other words, an alpha level of 0.05? So if you listen to that actual question or that research problem, hopefully you would have heard, I'm not saying if one was better or worse. Once again, I simply said, was there a significant difference between sleep at 8 hours and nights of sleeplessness based on students' test scores? So because I'm not saying where the difference lies, that leads us into our first part, our hypotheses. Our HO and our H1, which once again is tested against our population. Our population is our mu difference, although we deleted it. So mu difference equals 0. Mu difference does not equal 0. In other words, there is a difference amongst the 2 choices, or there isn't a difference amongst the 2 choices when we're comparing it to a population and not an actual sample. Remember, 0 is a theoretical 0 because it's a standardized distribution, so it could be anything. In this case, when we pull it, it'll come out to be, it'll come out to be 4.7. So if we're looking at this problem, think about the difference. So the difference, once again, just so that you won't forget, I apologize, just so you don't forget the idea of the dependent versus the independent versus the one sample. Independent, 2 samples. One sample, dependent, 1 sample, tested twice. So then what are we doing for the dependent t-test? We're looking at the difference score. So we're asking everyone, what was your post score minus your pre-score, or what was your preference of A versus B? And we're going to look at everyone and subtract them. Let's say we had 4 participants. So for each of these participants, we would ask them, what's your post, what's your pre, what's your post, what's your pre, what's your post, what's your pre? And we would get new values, right? We would get new scores. We would get different scores. So this is the different score for each person. What would we do to calculate an average? Which is the same process we always do. add them all up. So add up the different scores and divide by how many scores you actually had. 4. So this would give us then the mean difference. It is the difference between, right, the average difference between a pre and a post score, or two choices for one sample group. That's where this idea of this mean difference actually comes from, the different scores. All right, so I'm going to erase it because we need the space. All right, so step 2. Set the criteria. So we're talking about a criteria. We need an alpha level. And then what are we going to need? A degrees of freedom. What else are we going to need? How many tails we have, which will lead us to a T critical. So now that we heard the research question, decided, let's make sure that we pull all those numbers. I didn't write up there for you, but I'm going to do it now. So we can use all those numbers to then figure out our data. So I had said there was 25 students. I said the mean difference of their scores was 4.7. I said their variance was 18. And of course, I said that their significance level was 0.05. And because we had 0.05 and all we were testing was, is there a difference between their test scores when they sleep 8 hours, when they don't sleep 8 hours? But I didn't say if the difference was a good or a bad thing. I didn't talk about it being directional. That means we ended up how many tails, or a non-directional test, which led us to 2 tails, an alpha level of 0.05, and a degrees of freedom of n-1, so 25 minus 1, a degrees of freedom of 24, and we actually take that number and we start looking it up. We'll end up realizing we have a positive or negative. You can be on either side, the positive or negative side, of 2.064. So once again, what do we do in step 3? We run it and we compare it back to this number, and we make a decision based on our educated guess of our hypotheses to do step 4, actually make our decision. So let's look at step 3, which this one's pretty easy because we already have the mean difference, 4.7, so just plug it in. And then we need either one of these, a variance or a standard deviation. So what did I give you? A variance. So we're going to use this formula, right? So then we'll do the variance is 18 over the square root. I apologize, not that square root. The whole square root of the sample, which is 25. So in other words, 18 divided by 25, and then you would square root the entire thing. So 18 divided by 25 gives the square root of 0.75, which then ends up being a number of, 0.72. And the square root of 0.72 leads us to 0.85. That's the bottom of the formula. So 4.7 divided by 0.85 leads us to what value? It leads us to 5.53. So 5.53 is the comparison we do once again. Is this number bigger or smaller than 2.064? And if your brain, once again, is a little lost in what we were talking about, remember, there's always a visual here. I'm a visual learner, so I draw things out. Right? Our mean is in the middle. And this is saying that this is where our tail begins. Negative 2.64. 2.64. This is H1. Or in other words, the tail. All the piece in the middle is HO. So where are we? Are we in a tail? Or are we in a body? Are we in the tail, the extreme significant different area, which is here or over here? So in other words, there is a significant difference between these actual choices. So we're looking at college students in terms of their, I apologize, their problem-solving skills in terms of sleeping. And so when we look at those, we're saying that students that sleep versus those that don't sleep. So the answer is kind of common sense. If you get less sleep, you won't be able to perform better on tests. If you get more sleep, you perform better on tests. And just because you know the answer, it makes it very easy to do the APA write-up, which is actually step 4. So, step 4, T, degrees of freedom came out to be 24. Our value was 5.53. Our p-value was less than 0.05. So we were in the tail, right, in the significant area, and you write a paragraph. And you're simply going to write a paragraph explaining that process, saying that researchers want to determine the sleep effects of students' problem-solving skills. A dependent t-test was ran. A sample of 25 college students were selected. The results indicate there's a significant difference between those that have less than 8 hours of sleep and those that have more 8 hours of sleep as performing the task of test taking. And you would actually put T, degrees of freedom, 24, is 553 with a p-value of 0.05, meaning you landed inside the tail. So all you do is reword your actual research problem and add in all the beautiful symbols, giving it an APA write-up, and doing essentially step 4. But hopefully you've been able to see that you're not able to do step 3 without doing step 1 or 2. The whole point of hypothesis testing is to run these steps in order because you need each one to answer the other.